Hello, everybody, and welcome back to HVAC Training Videos. Good to see you guys out there in the chat again this week. We have a lot of great people out here that show up every week to learn on a Friday night. I can't even believe it's even happening. Who learns on a Friday night? You guys. That's who does. HVAC Power Factor, that's our buddy Doug. That's how we pronounce Doug's name. It's pronounced very low and deadpan. Doug. We have Ed, and that last name is Polish or something. I don't know. I should know it since my last name's Psioda and I'm Polish, but that's very difficult, and I'm not going to try it. Old Handy Luke. We have Steve, Eric Kaiser, our buddy. That's going to be on the show again soon. Clint Glasgow and T. Leck, and I'm just going to call you Thomas because I figured that out, and I just am very proud of myself. I pinned up at the top of the screen here. Guys, if you like this show, if you enjoy these shows, give the video a like. YouTube takes that information and makes me famous. So we need to get as many likes on these videos as possible and comments, and I'm pretty sure I can pass a lot of celebrity superstars if you do that. I'm sitting here at my desk. At my desk, I have this. I look at every single day. It's a Jeopardy calendar. I love this Jeopardy calendar, and I get about 50% of these correct. And the other ones I always go, oh, man, I knew that. The question for today is not HVAC related. It's just fun. A 1990s dance music style from England is called drum and this instrument. If any of you know that, I will be extremely impressed, okay? Drum and this instrument. Think about that. Guys, as you know, and I told him I was going to do this, and I can't help myself. As you know, I'm interviewing Captain America tonight. So hold your standards at that level. That's where we need to keep our standards for this interview. That's where we need to be at. I just want to put that out there. His name is Steve Rogers, okay? Steve Rogers. And about the third time I spelled it correctly, so I'm pretty proud of that. Oh, great. And there's a pronunciation of the name down there, Jonowalk. All right, thank you. Thank you. I appreciate that. Steve, that's the Energy Conservatory. We're going to talk about residential air balancing, and guys out there says, what kind of air balancing takes place in residential? Well, typically it's somebody calling you back after the job going, this room's way too hot. That's our residential air balancing that we're all used to. We're going to get a little bit more fine-tuned than that. All right, we're going to step it up a notch. So we're going to get to that in just a second. So I just want to remind you of a few things. Like I said, put a like on this video. If you haven't subscribed yet, watch the show here, and if you like it, subscribe. Tell your friends about it. When you go places, I don't care where you're going, whether it's a grocery store or what, tell them about the show. It might be awkward at first, but then they might like it, so it'll be all right. So I'm not going to sit here and talk for, an hour because, the feedback says, Zach, talk less, guests, talk more. I'm just kidding. There is no feedback. I just made that up. We're going to have a little commercial here for one of our supporters. We have a lot of great supporters. We have NAVAC, we have Yellow Jacket, we have EWC, Refrigeration Technologies. All these companies are great. You can find links to all those companies in the description here. We are partners with TrueTech Tools. So anytime you go over to TrueTech Tools and you purchase something, make sure you're using our Shop Talk discount code. It works on about 99% of the stuff there. I think there's a couple brands that don't allow it. I can't remember them offhand. It used to be Testo, but I think Testo, you can do it now. Fleer used to be one of them. I'm not sure if they do it now or not, but there's a couple of them which it might not work on, so don't be surprised about that. Guys, I hope you're excited. I hope you're ready to learn something tonight. So what I'm going to do now is we're going to take a little break here for just a second. Then I'm going to come back, and Steve will be with me, and we'll get into residential air balancing. The NP4 DLM cordless vacuum pump from NAVAC features a high-performance lithium battery capable of up to 1 hour of continuous running time. Weighing a scant 15.4 pounds, this unit is exceedingly efficient and, for technicians, easy to carry and store. The NP4 DLM's twin-cylinder operation provides high vacuum down to 15 microns. To save 8% off this product when you purchase, go to TrueTechTools.com and use our Shop Talk discount code. All right, we are back here, and as you can see, Steven is on the screen with me. I don't know why I called you Steven. I guess I saw your name there, and I just reverted back to Steven. How you doing tonight?
That's okay. If you call me Steven, I'll think it's my mother.
I know, that's the problem. That's what I think of. Zachary Steven, and I was like, what am I? I'm not on furniture. What's the problem?
Yep.
So
middle names are for.
Absolutely. That's the only time they're used. That and well, I'm not going to get into that. There's another thing they're used for, but that's in the news. So don't bring the show down. That's my mantra. So Stephen, we know like a little bit about you because I think some of these guys are familiar with you. So why don't you kind of introduce yourself and maybe tell us a little bit about the Energy Conservatory?
Okay. So I'm Stephen Rogers. By education, I'm a mechanical engineer, but please don't hold that against me. I like to say that technicians and engineers just know different things. It's not that engineers know everything. Definitely not the case. And my specialty for the last 25 years has been measuring pressure and flow. And more specifically, since I started working with the Energy Conservatory, airflow. And so if you're not familiar with the Energy Conservatory, you've probably heard of a blower door test or a duct blaster test. The Minneapolis duct blaster and the Minneapolis blower door are Energy Conservatory products. We're known as TEC. Sometimes people say Tech, or some people actually think the name of the company is Minneapolis, but that's actually not the case. But call us whatever you like. We're the Minneapolis blower door people. And so that's a little bit of background. I'm fairly recent to the company, just within the last 5 years or so. And I purchased the company from the original owner and founder named Gary Nelson, and he remains with the company. But that's a little bit about what we do. But today we're going to talk about some of our products that are a little bit less known. We make or made a flow hood called the Flow Blaster, and we have a air handler flow meter that is quite innovative, and people know what it is if they're trying to get an accurate measurement on air handler flow. So that's just a little background about who I am and what the Energy Conservatory does.
I think I know what you're talking about when you say the air handler measurement method. Now, are we talking True Flow? Is that what we're talking
True
about?
Flow. That's the one. Yep.
And the only reason I know that, well, I've seen it online, but I never owned one. But Bill Spohn thinks very highly of the True Flow grid.
Yep.
So he suggests that. He said it's the best way. Now, would you say that too? Is it the best way to get flow at equipment?
Yeah. I mean, pretty much hands down. And, you can say I'm biased about that, but I've got the data. Most of the other methods have some significant drawbacks. If you're using static pressure, and the OEM chart to figure out the fan flow, that works pretty well in a new system. But once it starts to get dirty, you got dirty squirrel cage, you got a dirty indoor coil. Now that chart of pressure versus flow, it doesn't really stack up anymore because you got a different pressure loss across that evaporator coil now.
That's absolutely right. That's very true. The older it gets, the worse it's going to be. Some are worse than others. Absolutely.
Yeah. And anemometers work great for single point velocity, but turns out that there's never enough straight duct to get a good anemometer measurement.
Now, are you referring to hot wire?
Hot wire, mini vane, pitot tube. They all have kind of the same strength and the same weakness, which is they're good at measuring velocity in a single point. But when you got a duct and you're too close to an elbow, eventually you have to take an infinite number of points to get accurate.
And infinite's very difficult.
Yeah. You could do almost infinite, like every half inch and get really, really close, but most people don't have the patience for that.
Every half inch on a large duct, that's quite a bit. And now, since we're opening with this, and we'll get to the situation at hand here, but since you said that, how much straight duct is really necessary to make that a more accurate measurement?
So it depends on which source you believe, but many sources say you need 10 hydraulic diameters. And if it's a round duct, hydraulic diameter is just the diameter. But of course, a rectangular duct doesn't have a diameter, and so there's this formula to calculate a hydraulic diameter. So for example, my return in my house is a rectangular return that is, I think it's 16 by 10, and I figured that based on what that works out to for hydraulic diameters, I would need about 12 feet of straight duct. Um,
Hard to come by.
yeah, you're not going to find 12 feet of straight duct in a residential system hardly ever.
No. And so you're in Minneapolis.
Yep.
So if you travel south toward the southeast United States, the straight duct sections get shorter and shorter until they just turn into flex.
Yeah.
So when you get to Florida, they're completely flexed with several pieces of duct board, and that's
Yeah.
about all you have. So, okay.
Yep.
Well, we'll get back to the tools used and the more accurate and less accurate tools out there. So let's just set the stage here for balancing residential systems. Because pretty much anything you say will be additional information over what people already have because no one balances residential systems.
Yep.
So why even should they when it has never been done? Obviously, the industry hasn't crashed and crumbled. So why should we even balance them at all?
Well, because there are some comfort problems that you can't solve any other way. It turns out that the handometer is not very accurate. It's even worse than an anemometer.
Yes.
And I'll hat tip to Ed Jonawak. I think he's the one that coined the term the handometer, where you just wave your hand over the duct and figure how much airflow that is. And it's not very accurate.
Yeah, I've used that one for years, and yes, it does. It senses temperature too, but it has a 20-degree swing either way.
Yeah. Yeah, it's even worse at airflow.
I didn't know that was possible. And let me just stop you right there real quick. So Ed down there in the chat, is that somebody I should be talking to on this show, would you say?
Yeah, for sure.
Okay.
Yeah.
I'll get him.
That's great.
Don't let me stop you, though. Go ahead and complete that thought.
So the problem is that if you don't know where the air is going, you don't know where you're delivering the heating and the cooling. And so an airflow hood and air balancing isn't always going to solve all your comfort problems, because many of them have different causes than that. But some of the time, it turns out that the problem is that you've got, two bedrooms is a pretty common case, where you've got a bedroom that's on the side of the house and one that's on the corner of the house. And they're both, let's say they're both 10 by 12 feet at 120 square feet. And somebody decided that, they're both the same floor space, so I'll both give them each a 6-inch duct and we'll call it good. Well, then what you end up with is the same amount of air going to both of those rooms. But if you do the room by room load calc, what you find out is that if you got a corner bedroom with 2 windows and a side bedroom with only 1 window, the corner bedroom needs approximately twice as much airflow.
Sure.
And so if you don't have an air hood, you don't have any way to know whether they're getting the correct ratio. I mean, it's not super important that they get exactly the right number of CFM, but it is really important that the room that requires twice as much heating and cooling gets twice as much air. Otherwise, it doesn't matter what, how many BTUs, if you got multi-stage system, you can vary the amount of heating and cooling that's going to all the spaces. But if those rooms one requires twice as much heating and cooling, but they're getting the same amount of airflow, then whether your equipment ramps up or down, you're putting the cooling and the heating into the rooms in the wrong proportion. And so the one that is getting proportionally more than it needs is always going to be over-conditioned compared to the other one.
Let me ask you a question. Let's say you do a block load calculation. So you have your 80 CFM for one room, 121 CFM for one room, and on down the line. But you're using standardized duct sizes. Let's say your company uses, and a lot of times it's like a 6-inch round, an 8-inch round, or the equivalent rectangular duct. So you're putting these standardized duct sizes in these rooms, but you followed a block load calculation, and you're putting in what the closest thing is to that amount, because it's going to vary a little bit. Are you saying that you still are going to have to fine-tune that after that's done because there's enough air in those?
Most likely.
Swing? Okay.
Yeah. Yeah. So you either need balancing dampers. Well, you need balancing dampers either on the register or, where the branch leaves the trunk. And that's the only way to control the airflow, especially if you're trying to economize by, not using 5-inch duct and 7-inch duct. But even beyond that, even if you follow the ACA design series and include the exact right duct size, depending on how many elbows you've got, you can get more and less airflow to a particular to a particular room just because you've got more elbows to one and fewer elbows to the other.
Right. Total effective length will change depending on how many elbows you have.
Exactly.
Or how many times the flex goes like this across the crawl space.
Yeah, right.
Right.
How many waves in your flex?
Right. And it makes sense. And it can be significant because I know depending on which fittings people use, going back to manual D, you can have one type of fitting that might be 50 TEL, and then you could change the type of fitting or maybe have vanes in it, and it could be a third of that or less. So it can be significant in that way, even though it's the same amount of air and the same size duct, theoretically.
Yeah.
So, interesting. Okay. So if we have a reason to do this, we're preventing customers obviously being uncomfortable in certain rooms. And that's what it goes back to. Really, you're going to have a happy customer from the first point throughout instead of having to come back and fix something.
Yeah. Yeah.
Okay.
And, so I think I'm not going to say that air balancing is required in all cases, but depending on, you got a new setup, if it's a new installation, air balancing is a really good idea on an initial install because you're never quite sure how those equivalent lengths are going to pan out once you start. The installed total equivalent length is a little different than what you're calculating with manual D. The manual D calculations are not super precise, and you sometimes get an airflow that's in between duct sizes, so you got to go the next bigger. That means you're going to get a little more airflow. And so I think it's most useful to use air balancing when there's a particular comfort complaint that you're dealing with, and you can kind of follow the symptoms a little bit because sometimes I got hot rooms and cold rooms. If the hot rooms are all upstairs and the cold rooms are all in the basement, then it's a different scenario where it might not be air balancing that is going to be the correct solution there. The hot upstairs is very often air leakage that's coming into the, I should say hot upstairs in the cooling season is very often because you got a lot of infiltration coming into that upper story. So it depends if you're talking about imbalance from floor to floor or imbalance between, the east bedrooms and the west bedrooms on the main floor.
So there might be some preliminary testing required before you air balance to ascertain whether or not that's an issue or you actually need to be closing dampers.
Well, I would say the first thing you got to do is understand the process and follow the symptoms. And this is, it's too much to get into today, but if somebody says I've got hot rooms and cold rooms, you got to start asking questions. Is it all the time? Is it just at night when the doors are closed? Is it in the heating and the cooling season? Did it just happen recently, or has it always been like this? You got to dig deeper to try and find out what the source of the problem might be. If somebody says it's always been fine and then something just went bad, well, maybe you got raccoons in your attic and they disconnected a duct.
That's exactly what I was thinking about whenever you were talking about that. So the difference between chronic and acute problems is that there was a raccoon in the crawl space. That's exactly what I was thinking.
Yeah, or you've got storage up in your attic and somebody dropped a trunk on the flex duct.
Or electrician crawled across it.
Yeah.
I don't mean to mention electricians by trade, but the shoe fits. They keep crawling across ductwork.
Yeah.
So
that was made to support humans, right?
It was made to support very lightweight humans. No, it's being in the field for a long time. It seemed like there was a chronic problem with electricians crawling across trunk ductwork, especially in crawl spaces where there was an equal amount of space above and below it, and below it was really dirty.
Yeah.
So no one wants to do that.
Yeah.
So let's see, where would you like to go from here? Do you want to talk a little bit about the tools, or do you want to get more into the process of what we need to do first?
Let's talk about the tools so people can have a little bit of an idea in their head what we're dealing with, and then maybe wrap back around to how the process works.
All right. So if you want to do residential air balancing, what is the must-have and what is the let's avoid this, if we can categorize it like that? What do they need to have as far as tools?
If you're trying to do balancing well enough to solve comfort problems most of the time. And I'll make a qualifier there that air balancing is not always going to be the solution to comfort problems. But if you want to be able to solve the problems most of the time, then you need an air hood, not an anemometer. I wouldn't say necessarily you have to stay away from using a mini vane or a hot wire, but yeah, this Alnor flow hood, this one I would call the minimum useful product. This one is a passive flow hood as opposed to a powered flow hood. You want to switch to the powered flow hood. This one's a powered flow hood, and this is the most accurate type of flow hood, because when we say powered, that means that inside that throat section is a fan that is taking a measurement of the pressure inside the hood, and it's going to set the pressure inside that hood to 0 compared to the room. What that means is that the hood is capable of compensating for the resistance that it creates. And if you heard my air balancing webinar I did with TrueTech Tools, I talked about insertion loss. Insertion loss is nothing more than when you put one of these hoods over a register, you're adding resistance, that makes the flow go down. So if you don't compensate for that somehow, you get additional error.
Would you say this is the preferred method, having a powered hood?
Yeah, I would say that's definitely the preferred hood. One of the things we can do is just kind of rank them in terms of accuracy. Powered flow hood is the most accurate way to go. The next most accurate is that passive flow hood that you just showed, this one. Although there's a caveat here, and that is that the testing that we've done shows that you've got to have the residential sized hood, which is this particular one here. There are larger ones that have a square throat in them. This one with the smaller round throat is appropriately sized for residential airflows, but the bigger ones that have, big 2 foot by 2 foot entrance into the hood, those are intended for commercial airflows. And our testing shows that they really are not accurate enough for a residential job in residential airflow.
So you would say this is a low volume hood?
Yeah.
Okay. So we have the CPS as well here. It's one of the ones you tested.
Yep, this is one of the ones we tested, and maybe after we talk about this, we can jump to that slide that shows the results of our testing, because I've actually got more information about this particular hood since we did our testing, and that is some of you might know Michael Hausch, shows up in a lot of HVAC forums. He did some testing. He balanced a house using the CPS hood, and then he made all the same measurements with the Energy Conservatory's Flow Blaster, which is, according to our testing at least, the most accurate flow hood that has been available, although it's no longer available. And what he found was that the accuracy of this hood, once you get below 50 CFM, it kind of falls off the cliff. It gets even worse than what we tested. And we didn't see that because the lowest flow we tested was about 50 CFM. We didn't go any lower. And of course, residential air balancing, there's going to be a lot of registers that are below 50 CFM.
Sure. All the 4-inch outlets will be teetering below that. And this one has a baffle for below 50 CFM, correct?
Yeah. Yeah. We tested according to the manufacturer's instructions, you're supposed to use that baffle when you're below 50 CFM. And so we tested at 50 CFM, and we tested both with and without the baffle. So you can sort of imagine that if we had tested it at 49 and at 51, the results wouldn't have been any different. But,
yes. Yeah, absolutely. All right. Well, these are your findings here.
Yep. So let me orient you on this graph a little bit. The first thing to notice is the red box there that's at 0 and 0. The red box is kind of the accuracy target, and a flow hood, if it has better than 3% accuracy and less than 3% insertion loss, all the data is going to fall inside that red box. So that's kind of the bullseye. And if you look at the left and right on here, it's the insertion loss or the change in the flow. When you put a flow hood on a register, two things happen. Number one, you get a measurement. but number two, it can change the flow. So moving left and right on this graph shows how much the flow hood reduced the flow. And you can see that hood F and hood B are the two clusters off to the left side of the graph. And that's showing that, hood F was between 20 and 25%. That's how much it reduced the flow. Hood B reduced the flow even more, between 25 and 30%. So that's what we call insertion loss. In other words, you insert the flow meter or the flow hood onto the supply register and it changes the flow. All the other hoods, the insertion loss was between, plus or minus 5%. So all the other ones were pretty good. But now we want to look at the vertical axis, and that's just plain old measurement error. So if you look at hood A, for example, hood A measured anywhere from 25% high to about 42% high, depending on where you arrange it on the supply register. So each one of these circles has a cluster of measurements in it, and each one of those measurements is putting the hood on the supply register in a different orientation. So did we put the supply register in the corner, on the side, dead center? Did we rotate it? That's what all those 6 different points are. Then you can see hoods D and E, those are the 2 powered flow hoods, and those ones come really close to the target. Hood C is that Alnor Jr., the smaller sized passive flow hood, and it does pretty well. You can see that, accuracy, in some cases you're approaching minus 20%, which is not outstanding, but at least there's not a significant insertion loss on that. And so hood F is the CPS easy hood. And you can see that the cluster down at the lower left, that is with the restriction plate. And then without the restriction plate is, more toward the center. And so you can see that without the restriction plate, it depends heavily on exactly how you orient it on the supply register. But in hood, with the plate, it depends on that less, but of course you're getting that large insertion loss too.
And there's quite a swing when you have no plate, looks like. You go from over 20% to down to negative 20%.
Yeah. Yeah, exactly.
Now, can I ask a question here? You have hoods A and C, which are passive flow hoods, correct?
Yep.
So since they had above 0% as far as insertion loss, how did it have above 0% as far as insertion loss?
Yeah, so you might think of it, that's an insertion gain, right? And it turns out there's another slide in this presentation that shows what happens when you measure on a tiny 2-inch jet of air coming out. And in that case, some of the hoods had significant insertion gain. So what that means physically is that when you put the hood on the supply register, the flow goes up. And that sounds very counterintuitive, but it actually does happen. Normally, it doesn't go up very much, but it's some weird aerodynamics that's happening. And what if you want to research a term, it's called static regain. And essentially, the hood can be just perfect that it actually, how's the best way to put this? It helps the supply register recover some pressure, and that increases the flow. It more gradually slows the air down compared to if the air were just spilling into the room.
Oh, that's interesting.
Yeah.
Okay. Well, the other thing I see when I look at this is that looks like the powered flow hoods are the most accurate.
Yeah.
So that looks like, because they're right on the line there with being centered inside that box. And the closest one otherwise looks like C, but C, I guess it was the Alnor Jr. you said still goes down to a negative 20%.
Yeah.
There in some of the positioning.
Yeah, and this one's a 2x12 inch. This is the kind of register you typically get on a toe kick. And it's one of the more challenging ones because you kind of got this sheet of air and it just doesn't lend itself to being measured very easily.
Makes sense.
But,
yeah.
Yeah, another thing to point out is the difference between A and C, because those are essentially the same technology. It's a passive flow hood. but A is just way too big to measure this kind of flow. And so you get these large errors.
Oh, interesting. Okay. So A is, what hood was that again?
It's the TSI/Alnor full size flow hood.
Okay. All right, I want to write that down while we're going through here. And I have to ask, what is B way over there on the left?
Oh, so B is a 4-inch vane anemometer with a funnel made by Testo.
Oh, okay. So the one with the funnel sold separately, you can clip them together.
Yeah.
I think I know which one. I guess that's the 410, isn't it?
I don't know the model number off the top of my head.
It's going to bother me now, but yeah.
Yeah, the interesting thing about that one is the accuracy was always pretty good. It was usually within, I mean, this is, worst case is about 12% there. That's not bad. It's just the insertion loss. That 4-inch vane, you start stuffing all the flow through that 4-inch vane, and it really slows down the flow.
Yeah, I think I think it is a Testo 410, little handheld, large vane with the cone they put on it. And I can see where that would be very restrictive because that's what a 4-inch opening is. Are any of these anywhere near that as far as restrictive opening? I think even the CPS is larger than that.
Oh, yeah. Yeah. Well, although, the CPS, if you have that restrictor on it, it's probably smaller than the 4-inch, but it doesn't, you're not turning a vane. And there's some loss associated with turning that vane too.
I got you. I can see. I remember the little plate on it. It does make it significantly smaller.
Yeah.
Okay. Oh, well, that's interesting. So powered flow hoods are really, if you look at this and you can afford it, I'm guessing powered flow hoods are more expensive is one of the reasons why the other ones exist.
Yep.
So, and then it goes all the way down to, I think the Testo 410 even costs more than the CPS flow hood, if I recall correctly, with the cone.
Yeah, that probably is right.
Because it includes the word Testo.
Yeah, it could be.
For good reason. I'm not saying that just to be funny. I mean, it's good reason. They make good products. There's their flow hood. I think it's the 420.
This was not one of the hoods we tested, but I believe the results of this are going to be similar to that TSI Alnor full size hood, just because it's so big.
And we're talking about A up here.
Yep.
Okay.
Yep.
Interesting. Very interesting. So hoods, from this conversation, I get that hoods are the way to go with this sort of activity then.
Yeah. Yeah, you could do it with a large vane anemometer, a mini vane anemometer, or a hot wire anemometer, kind of waving it over the register, but you could really end up chasing your tail because that measurement is inaccurate enough that you could think you have a problem and you don't, or you could think you're okay and you really have a problem. And if you don't have confidence in the measurement, then, it could end up being, or, causing more problems than it solves. And nobody wants that kind of a measurement.
I'm going to bring those up since you mentioned them. There's a mini vane from Yellow Jacket. And here is a hot wire, just a generic hot wire. But a lot of people make these, and I just have for reference also static pressure. Since we talked about that, a lot of people are familiar with that. I think most guys are most familiar with static pressure, but that's at the equipment where you're using that. So let me take those off of there. Because I'll put it back up. I used a vane for a long time. It looks very similar to this. In fact, the same people probably make it. It was a UEI vane. Mm-hmm. And I'll just be honest with you, for several years I used it incorrectly anyway. On the return, I was putting in a restriction or a K factor, and Bill's like, you don't put in that for the return. It's blowing into it, not out of it. Mm-hmm. So there was about 10 years of my life where I was putting in the wrong numbers, and that's what we're trying to prevent here today, really, Steve.
Yeah. Well, and in the interest of helping to prevent that, a lot of people have shied away from trying to make airflow measurements because they can be so challenging. And if you don't have the tools that you can have confidence in, a lot of people have bought tools, they've tried to do it, and they're just not getting anywhere because they don't know which tools are accurate, which tools are inaccurate. And like you said, there's a lot of technique to it on the more challenging ones. And that would turn anybody off to trying to do better. If you go to all that effort of buying the equipment, trying it out, and you're just not getting anywhere. And so that's where it's important to learn which tools you can have confidence in. It's similar in the total system airflow going through the air handler as it is with air balancing. If you don't know what you can have confidence in, then you end up chasing your tail, and that just it just turns people off, and they say, oh, it's black magic. It can't be done. When what really was the case is they didn't have the right tools.
Right. The excuses will definitely flow. I think some of them have come out of my mouth before. This is not a lab. This will never work here. I don't even know what that really means. Like tools only work in a lab. And Eric is saying that the yellow jacket is a large vein. A mini vein inserts the duct on a probe. So a mini vein, then we can clarify that this is a hot wire. But there might be a mini vein where it's a tiny vein inside of the end of one of these probes. Is that accurate?
Yeah, that's how they look. They're typically going to be bigger than a hot wire. You typically have to drill a hole that's closer to 3/4 of an inch to get a mini vein in.
Okay.
Hot wire you can usually get in 1/4 3/8 inch.
Yeah, they're tiny. Yeah, because I've had the STA2 from Field Piece. I think it was the hot wire. Yeah. I've never been, because we don't have those long stretches of duct. I never really got into using a hot wire. I always used a vein at a return grill for doing mass airflow, even though we're ignoring. And let me go ahead and transition into that. So I was making measurements at return ducts for total system airflow a lot of the time.
Yeah.
But between the return, the equipment, and then back to the supply, you can have a lot of air loss. A lot of things can happen. So how do you quantify that issue when you measure at a grill when some of the air is blowing out in the crawl space or blowing out in the attic or something like that?
Well, I mean, that's what our duct blaster is for fundamentally, is to actually measure exactly how much air are you losing in the system. So if your crew's not familiar with duct leakage measurements, that's what it's for. Fundamentally, that can be measured. You do a duct leakage test, you mask off all the ducts and you pressurize the duct to 25 pascals and you measure how much air it takes to do that, and that's your total system duct leakage. And then if you want, you can then separate the supply from the return by masking off where the return comes in, and then you can decide determine how much of that leakage is on the supply side and how much is on return. So duct leakage can be another real significant source of discomfort and what seems like an imbalance. In the Midwest, where I'm from, we have some tremendously leaky ducts because they're usually in conditioned space. Usually our air handling system is in the basement, and most of the duct work is in or under the main floor. But so we're not losing a ton of energy if we have leaky ducts. But what we are doing is doing a very poor job of getting the air delivered to where we want it to be. And so in my house, even if I close all the supply registers in the basement in the cooling season, my basement is much cooler than I want it to be and much cooler than the main floor because there's so much leakage that just pours into the basement.
That is funny. I guess a basement doesn't really require a whole lot of air to stay cool.
Yeah, and that's the thing. The amount of cooling load in a basement in Minnesota, it's like 3% of your cooling load is required in the basement.
Sounds about right.
And so if you want it to be comfortable, you got to get only 3% of the air into the basement, and that's hard to do when it's leaking 20, 30, 40%.
And when you talk about stuff like that, I think back to Manual J. We're talking about load calculations and how well they're done and how well they're executed, and something like you're saying, where you have below grade walls, where you're sharing a thermal barrier against the earth, which is going to be relatively cool in the summertime versus the air above, and how many load calculations are inaccurate. Yeah. So, and that might lend itself to what you're trying to tell us about here today, because if you have an inaccurate load calculation, all of a sudden you have a calculation that says this basement needs 350 CFM when all it really needs is 80 or something like that, or 60 or something really small. So they're going to put a 10-inch round duct down there, or a 10 by 8 rectangular duct down there with some takeoffs off the side, and it's going to be incumbent upon someone like the hood user to come along and solve that problem later, because it's going to be awful.
And that's the case in the cooling season, but remember in the heating season, you might have earth on the other side of that basement wall that's at 50 or 60 degrees.
Right.
And so now you've got to try and keep that warm. So Alex Meany, if you know who he is, he's the trainer for Right Soft. And he talks about, you might need to do a rebalance seasonally. And, that sounds like, way over the top for comfort, but, at least in the Midwest, everybody kind of knows you got to shut your supply registers in the basement in the summertime. That may be all it takes, really. But, you do definitely require a different amount of air in a basement in the cooling season than you do in the heating season.
It's very interesting because we're bringing in several different ACA manuals now. So it's going to be a good show. We're going to talk about it.
Right.
We got D, we got J.
Yeah. So you mentioned the manual J, and, you've got to have room by room loads, and really kind of for cooling and for heating, depending on, what you learned about the comfort problem. Does the comfort problem only happen in the cooling season, or does it happen in cooling and the heating season? And that's a clue that can lead you towards, okay, well, do I need to get the room by room loads for all the rooms in both seasons, or can I make some guesstimates? And I would actually say, coming back to the earlier question about the process, I think there's kind of two processes that you could follow. One is really informal, almost seat of your pants, and you can get pretty good results from that. And the other one is to be more formal and say, okay, here's my manual J airflow requirements for heating. Here's what they are for cooling, and I'm going to get out my flow hood and I'm going to match those airflow requirements.
So what happens when you have two different requirements for separate seasons? One, maybe a bedroom needs 85 CFM and then it only needs 55 the other part of the season.
So when you do the balancing, if you look at manual B, there's a balancing manual. ACA manual B talks about balancing. And what you're going to do is you're going to divide up the airflow for the maximum of either. So when you go through manual J, you get your room by room loads, then you take the larger airflow of the two, and that's what you design your duct to. And then I can't remember the process for manual D, which one you use, but let's see. Yeah, I'm not sure.
There's a lot of ACA manuals floating around now. Now we have B, D, and J.
Yeah, right.
We're not going to go into S or T or anything tonight.
And that's what you can talk to Ed Johnawak about.
Hey, look at that. That's what we call a segue here.
Yeah.
Ed, I don't know if you're still out there, but in a non-ominous way, I'm coming for you.
Yeah.
Yeah. Well, that's one of the curiosities I would have. Here, where I'm at, we're in the southeastern United States, so we're only concerned, or 99% of our concern is cooling, because it is hot 9 months out of the year, or at least warm enough where we might run the AC. So everything is sized for cooling, all the way down the line, because our loads are so mismatched. So if you would have sized it for heating, we'd have some whistling ductwork and high static pressure. So it's a little bit easier for me, but someone in the Midwest, it might present more of a problem where they might have to do some sort of
It's actually
process.
the opposite in the Midwest. We end up, because we have large furnaces and small air conditioners, it's actually more common for people to have airflow that's too high than airflow that's too low, because they just put in the 120K furnace and they put it on maximum airflow, and that's usually too much for cooling.
Yeah, that's a real grill lifter. 120.
Well, and the worst thing that it causes is it causes high indoor humidity, because you're oversized, which means it's not running enough. And then, of course, when you're running at 550 CFM per ton, you're not doing as much dehumidification. And so, you get people where the thermostat says I'm at 75, but I'm not comfortable. And the reason is because if they measure the relative humidity, they're like 67% relative humidity.
Yeah, we face that problem down here too. Low latent removal compared to total capacity required. And it's a lot down here. I mean, it's humid all year, even in the wintertime.
Yeah.
It's very interesting. So we talked about our tools. We narrowed down our tools. We talked about the processes here. Let's see, what are we going to mix it up with here? And we know how much air needs to be measured. Your target airflow is going to come off your manual J, correct?
Yeah, that's right.
So
let me talk a little bit about the processes that I would suggest. I think we talked a little bit about the formal process, and that is, to get your room by room loads follow the manuals, which tells you how many CFM you need to each room. And then you measure, you begin the process with all the dampers all the way open. And then you figure out which are farthest from the target, and well, actually, which is farthest from the target in the high flow direction, and you start closing those dampers until you bring everything into balance. So it's a little bit of a back and forth process where you adjust a couple dampers, take your two that are the highest. So maybe, if you're in perfect balance, then that means everything's at 100% of what the target's supposed to be. But if you open all the dampers, you can probably find that, you got one room that's at 170% of what it's supposed to be. And you got another one that's at, 50% of what it's supposed to be.
Absolutely.
So you start with those ones that are too high, and you start closing the dampers. And as you, close the third and the fourth damper, what you find out is that first one you closed, now because you've closed a couple more dampers, that one went back up a little bit. And so each time you close a damper, you're affecting the other ones. The air is squishing out wherever it can find the path of least resistance.
Now, on a standard home, how much time goes into this process on average? Is that something that you can quantify for us?
I actually haven't done that many of them in the field. That would be a better question for somebody who does this. The couple people that I know do it pretty routinely. Neil Comparetto does it a lot.
Good old Neil. Yeah.
Silas Hepner out of Iowa does a lot of air balancing. Those guys could answer that question a lot more precisely than me.
Well, I know Neil Comparetto already, so I'll go track him down.
Yeah.
He'd be good on the show anyway. He's a good guy.
But, if you want to pull up that slide with the as designed slide, this I'm going to use to illustrate the kind of more informal seat of your pants balancing, because this one we didn't actually have room by room loads.
Here's how you need to speak to me. Green circle, yellow circle.
Yep. Or yellow circles.
Yellow circles. All right.
Yeah. Okay. So this slide is the as designed and built home. This is a home that we, outside the Twin Cities here, we did this as kind of a ride-along example of understanding air balancing. And I want to point out specifically in the second floor, which is this is the floor plan. The one on the bottom is the main floor. One on the top is the second floor. And if you look at what we've shown here, each of the yellow dots is sized according to how much air was coming out of that supply register. So, for example, bedroom 1 had 54 CFM, bedroom 2 had 44 CFM, and then the master bedroom, or the master suite, which includes that bathroom, walk-in closet, and master bedroom, kind of occupies the other end. And that one had, 21 coming out of each of those 2 supply registers, 8 coming on the walk-in closet, and 2 in the master bath. If you add those together, and when I say seat of the pants here, I'm going to describe here. If you look at this floor plan, what you notice is that bedroom 1 and bedroom 2 add up to about the same amount of exterior walls and about the same number of windows as the master suite does. Each of those occupies, one end of that upper floor. That means the loads are going to be similar. And so without doing a manual J room by room load calc, you could look at this floor plan and you can say, okay, bedroom 1 and bedroom 2 should add up to about the same as all 4 supply registers in that master suite. But what you have right here, I'll do the math for you. In this condition, those 2 west bedrooms add up to 98 CFM, and the 4 registers in the master suite add up to 52 CFM. So you get almost twice as much air going to bedrooms 1 and 2 than you do to the master suite, but you kind of logic through that they should be about the same. So go to the green circles slide.
Thank you for using circles.
Yeah. So after we close the dampers to bedroom 1 and bedroom 2, and now what we have is we got a condition where we've got 77 CFM in those 2 bedrooms on the left, and the master suite is about 70. And the family who lives there told us that after we did this, that comfort was significantly improved, and it was felt very well balanced. And we didn't do a load calc. We just sort of went seat of the pants and said, okay, there should be about the same amount of air going to the one end of that second floor as the other end of the second floor. And that's what they told us. We didn't dial it in exactly, but we got close.
Now, if I might ask one question about this, is this house, would it be classified as an energy efficient house?
It's pretty good. If you go to the Jones home one with the photo of the house, this is the house here. It's a 2-story colonial. It's about 3,100 square feet. It has a full basement as well as the two floors above grade. And it's got 2x6 walls and a well insulated attic. And air tightness we measure with a blower door at 2.4 ACH 50. That's really pretty good. So this house was built before there was an energy code in Minnesota, but it was built pretty well. So this is not like a net zero energy home. It's not a passive house. It's just fairly energy efficient, fairly airtight house. Many of your listeners might not be familiar with what 2.4 ACH 50 means. The energy codes in many states require you to get air tightness of the house below a certain threshold. So ACH 50 stands for air changes per hour at 50 pascals. So 50 pascals is the test pressure. So with a blower door, you bring the house up to 50 pascals, and then you measure how many CFM of leakage is coming out as you blow the air in. In this case, it was 1,010 CFM at 50 pascals. So then you take that 1,010 CFM and you divide it by how many cubic feet was the house, and that gives you how many air changes per hour you've got. And in the colder northern climates, the energy codes in most states require you got to be less than 3 ACH 50. And in the warmer southern climates, it's usually you got to be better than 5 or less than 5. So this would meet energy code requirements in any state.
The reason why I asked you originally was that when we go back here and see the total flow at 610 CFM, it's a really low flow for a big house like that, 3,100 square feet. So that's a 1.5 ton system, maybe a 2-ton system.
Yeah. It's a 2.5 ton, and it's a little low on the airflow.
Okay. All right. So it's just running less than 300 CFM per ton.
Yeah.
It's interesting. It's extremely low. Well, okay. Yeah. Well, it's still 2.5 tons on that house of this size is still.
Yeah.
Well, I'm down here in North Carolina too, so it's cooling size.
Well, and typically, are you going to have 2x6 walls and double pane windows and well insulated attics?
Not until recently. My house has 2x6 walls, but the last one I lived at, and every one before that was 2x4 walls.
Yeah. Okay.
So it'd be more common.
Yep.
Very interesting. I'll take one more look at that right there. And actually, I'm going to compare it with the yellow again one more time so people can see the difference.
Yeah, let me point out one thing on this slide. So after we did the air balancing, we went back and we did a load calculation. And if you look at the blue circle where it says proportional to manual J, if we were perfectly balanced, all of the green circles would be the same size as the blue circles. You can see that they're not exactly, but the bedrooms upstairs are pretty close. However, if you look at the main floor, the living room and the family room, a lot of those are pretty far off, but they had no complaints about comfort on that main floor. And the reason for that is because the main floor is a wide open floor plan. If you look at the floor plan carefully on here, it's not very accurate, but there was actually large archway openings between every space on the main floor. And so as long as you got the right amount of air going to that floor, it's going to be okay.
For people looking on their phones that might be watching this, the ductwork looks like it is superimposed on the bottom floor. So that's probably what you're seeing and maybe thinking it's walls or something like that.
Yep, that's what that is. There's more to that story if you want to watch a webinar, but that's the nutshell version.
And I'm going to suggest that because that's where these slides originated, was a True Tech Tools webinar that you did. It's been at least 2 or 3 years. Is it longer than that, or?
I think that's about, I think it's 3 years ago.
Okay. And I watched that webinar. I think it's an hour. I don't think it was a couple hours.
No, it wasn't 2 hours. I think it was, right about 45 minutes or something like that.
So the reason why I'm saying that is because our guys have plenty of time to watch a 45-minute webinar to learn about this. 2 hours, people start complaining and rolling over and stuff like that. But 45 minutes should be fine. And it was really informative, especially just for the study on the hoods. That was really interesting. You got to see your rig that you have down there in your lab where you tested the stuff. It's really, really cool. So that was really neat. I enjoyed that. And I want to ask this question. I know we're going to be running out of time here shortly, but there's a couple things I wanted to ask you. In fact, the first thing is, okay, in a perfect world, are you doing a multi-step process here to fine-tune this? I mean, you have your seat of the pants where you're going in there and you're just making your adjustments, not based on manual J, but based on comfort concerns and evening things out to suit those. In a perfect world, the duct blaster should be done. The blower door should be done.
Yeah. And again, this is too much to get into in this podcast, but you got to follow the symptoms. In my house, for example, I mentioned it's always too cold in the cooling season in the basement. Even if I close all the supply registers. Well, that tells me it's not an air balancing problem, and it's not. It's a duct leakage problem.
Absolutely.
Okay. If you close all the supply registers and you're still getting too much cooling, that's leakage.
So a little bit of intuition is okay.
Yeah.
All right. So that might cut out some of your work if you can sort of do a little bit of diagnostic work as well then.
Yeah, exactly. And the other thing I would point out is even if you've done a manual J and you've balanced the airflow to what it's supposed to be to each room, you could find out that, you've got one room where the load was way more or way less than you thought when you did the manual J. And there's one of the people that works for us has a house where all the windows have been replaced except for the one in the living room. And so that one's an old single pane that's not very well sealed. And of course, the solar heat gain coefficient on that old window is probably 0.8. And all his new ones have a solar heat gain coefficient of like 0.2. So the cooling loads are going to be way different than you expected if you assumed all the windows in that house were the same.
Absolutely.
Or when you start getting into bonus rooms above garages, that's a case where they're notoriously leaky. Anywhere you've got knee walls that don't go all the way, from the floor to the ceiling, those knee walls are notoriously leaky. You get leakage under the floor below the knee wall. And so now you have a case where manual J is going to assume that all of your infiltration is evenly distributed through the house. But if you have a bonus room, you're almost every time going to have way more leakage in that bonus room per square foot than anywhere else in the house. And so that's a case where if you did the manual J and you let it assume that the infiltration is uniformly distributed through the house, you're going to be wrong and you're going to need more cooling than you thought in that bonus room.
And one thing I'll add to that as someone who's done manual J's, and sometimes, like, I live in a modular house, and the loads are done on these houses, but they're not done for the orientation of the house and the final product. And you have north facing, which is significantly in cooling, and heating is not the same effect. But in cooling, a north facing orientation is way less as far as load than a south, or even east and west are the worst. And then it goes south and then north. So if you do a load calculation, you have a corner bedroom, and you do your load calculation, you don't know which way the house is going to face, so you have to choose arbitrarily north, south, east, or west, or whenever they engineer these things, they have to just, I don't know how they quite do a modular house because they don't know which way it's going to face. But all of a sudden you have an east-facing bedroom, and every morning your bedroom's 4 degrees hotter. So there may be some things you have to add on to a well-engineered house in order to fine-tune that. So.
I don't know how many of you know Russ King, but he's got load calc software called Quick Model. And he likes to show an example where exactly the same house changes from a 3.5 ton house to a 5 ton house by rotating at 90 degrees.
Right on. Well, whatever side the sunroom's on.
Yep.
Because that is one of the biggest things. You can have a sunroom, and I don't remember all the different coefficients or heat transfer multipliers, But even if you have something where you're going like the different windows, like you have single pane, which is an older window, versus double pane, it's significant. So there's a lot of significant things, like you said, you could replace every window, but the one single pane, and it just causes you endless headache because it's so much worse than the other windows. It's like two
or
or
a
three
house
times.
or a house that's been added on to. If you've got, I live in a 1958 house, and I just added on a few years ago, and I know that the new walls are way tighter, way more insulated than the old ones. But if you didn't know that going in, you might assume all the walls are the same, and it's not even close. And when you get a house that's been added on to recently.
Absolutely. That's an interesting thing, because if you redo or renovate your house, or even you're adding on, it's well taken care of inside. Someone does a load calculation, it's like, well, this is all going to be, and you go to 1958. I don't even know if these walls are insulated.
Yeah,
That's what you're thinking for the entire house. Yet you have R19 in the walls out there, or spray foam, or something like that. Yeah, absolutely. There's a lot of things that don't factor into the engineering of the house that change over time, and people do things without permits and things like that, so you never know what's going to happen.
Yeah.
You have to deal with later.
Right.
I know everybody out there like, no way. Yeah, no way. All these guys get permits that are watching.
Yeah, I'm sure.
Some of these regulations that they're avoiding: duct blaster, blower door. Yeah. Right on. Depends on where you're at.
There's good reasons to do it, just to help you troubleshoot. The people that understand the building science and the air leakage and the duct leakage, they end up getting bigger jobs and making more money because they can solve the problems that, a homeowner's been through 3 HVAC contractors, and they don't know how to solve that problem until they get to somebody that really understands the building science, can test it out, and they're willing to pay a lot more to solve those problems.
That is a constant thread for the people that I have on this show. Yourself, we have Eric down there, we have our buddy David Richardson from NCI. We all say the same things. You're going to do something, and you're going to test something that other people don't test. And that's what's going to set you apart. And that's what's going to give you work, because you're going to test something that needs work. That's how you get work. So,
and pretty soon, you start to build a reputation as the guy who can solve problems. There's a guy that, I don't know if many of you know Jenry Garcia, but it just kind of word of mouth, other HVAC contractors figured out, I can't figure out what's going on, so just call Jenry.
It's odd that you say that, because he's going to be on the show probably in March. I've been talking to him.
Nice.
He's in the preliminary process of coming on the show, so we're about a month out or a month and a half out from having him on. So it's interesting. Everybody knows each other here.
So should I just send the microphone and borrowed right to Jimmy?
Well, when I sent him an email, I said, do you have, because that's one of the things I always say right at the beginning, just like I said to you, said, what kind of audio video equipment do you have? Then I always say, tell me exactly what it is, because people will say, I've got the stuff, I'm good to go, and then they'll have like headphones with a little mic on them, and that's what Jenry has. It's like, unless you mean an Apple headset, then no. I was like, okay, great. So maybe you will be sending it to him, but probably not. It'll be a couple months out still. But I look forward to that. Well, we've come up on our hour already, and just like every other interview I've ever done in my entire life, we didn't get through everything, and there'll still be more to come. I want to give out some of your information, your personal information, and I want to go ahead and say there is a website here, and I'm actually physically show you what the website looks like on the screen. And I'm going to give you the actual website address. Let's see if it'll superimpose over that. Maybe it will. Yes, it will. Very good. So there's the website right there, and it's in the description of this video as well, so you can find it there.
Yep. And stay tuned. We've got, in the next couple months, we got some really good total system airflow training. We're going to talk about all the different ways that you can measure airflow, and it'll be, there'll be links to it on our website in the coming months.
Now, what training do you guys offer? Is it all virtual training? I mean, if someone wants to be trained by you guys, or obviously they can come buy your products as well.
Yep.
What do you offer? Is it just webinars?
So we've got quite a few webinars. Every summer, except for COVID, we've done a train the trainer session. It's really aimed more at educators, people that are training. But we've had, HVAC instructors. Usually, if you're looking for a training on, directly from us, it's mostly virtual if you're a practitioner. But if you're an educator, there might be some educators in your listening audience that might think about coming to one of our trainers. We usually train the trainers more than we train the people that actually use the equipment.
Oh, okay. Well, interesting. Yeah, we have a few educators down there, I see. And there'll be some more along to watch it after the fact and then more on the podcast.
Yep.
So some of you might be listening to this as a podcast. If you are, if you go to the HVAC Training Videos channel, you can see these recorded live, which is what we're doing right now. But in the future, that'll be the past. So we won't get in any psychedelic conversation like that. But just again, we're talking.
You got a time machine for us?
Nope, still working on that. Still, it's just a pile of screws outside. Every time I want to build a time machine, I just make a 2x4 shelf because that's what I'm capable of. And as you see, I'm still here. I'll be back making sports bets if I had a time machine. But Pete Rose here. I want to get to the Pete Rose conversation again. We had that at the house yesterday.
Right.
We're trying to advocate for Pete Rose. So no, I don't know how into sports you are, but we were sitting in a restaurant and it showed the class of Major League Baseball's Hall of Fame, and no one made it into the Hall of Fame. And I was looking at the list and had Barry Bonds there, someone who's got the all-time home run record now, and but tainted because of some of the things that happened late in his career. And I was like, we can't let Pete Rose in, but these guys are going to make it eventually.
Right.
It bothered me, but that's for a different show. That's for Steve and Zack's sports show. It hasn't been invented yet and probably never will.
Yeah, you don't want to listen to me, or you don't want to listen to me talk about sports. I haven't followed them since I was in college. So,
well, I can tell you who was on the 1992 Braves and Pirates, and then it gets a little foggy after that.
Yeah, I can tell you who was on the '87 Twins when they won the series in '91.
I bet Kirby Puckett was on that team.
He was indeed.
The late Kirby Puckett, unfortunately.
Yeah.
Okay. Well, is there anything else you want to add to this before we get off the air?
No, I just want to say it's been fun, and thank your audience for joining us. And reach out to me. I think if you want to put my email is srogers@energyconservatory.com.
I'll add that to this. This is the website. Which are you listing the contact information at the website as well?
I am not.
Okay, so I'll get that. His actual email.
It's on the last slide if you have it.
Yep, you're right. It is on the last slide. I did forget. Look at that. There we are.
There we go.
Absolutely. There you are. I'll leave that up there for a second so you can see it.
Yeah. So we do have quite a bit of online training. Some of it is getting a little dated, but we're looking to refresh that. We've got great tech support people. Reach out to us if you're interested in what we're doing. Want to try stuff out. Also make a plug for the brand new manometer. We just a few months ago released a new manometer called the DG8, and the objective of that was really to reach people like your audience. If you're into manometers a little bit, you probably know that if you want a manometer that's capable of measuring room pressurization or combustion appliance zone pressures, or whether the entire house is being pressurized or depressurized because of duct leakage, the manometers capable of measuring those measurements have been, upwards of $1,500. It's a blower door type manometer that's required for that. We've just released a new one that is a single channel specifically for those kind of measurements. That's only $549. So we're really kind of changing the game there and making it easier for people to make those precision, low pressure measurements.
I know somebody in the chat had mentioned that they have that or like that one. I think it was Doug. Doug, I don't know if you're still here, but DG8. Yeah, well, no, that's Eric. Eric said the DG8 is really nice. It was Eric Kaiser.
Yeah. Yeah.
So, Eric. Okay. Well, Steve, I really appreciate you coming on the show. I mean, this will be the first of multiple visits. So
I'm happy to be back. We got lots more stuff we can talk about.
I know, just from the list I have here, there was more stuff, and we already discussed a few in emails over the last month or so. I know we had a few other plans. I thought this was a good place to start because a lot of people, when like we said, residential air balancing, people's like, no, we don't do that. We have dampers on it. When people complain, we shut off dampers.
Yep.
And it's a little bit more to it than that, as we found out tonight.
Yeah. Well, and it depends, maybe that's adequate in a lot of cases, but when you get the tough situations, you got to start measuring room pressures and airflows and figure out what's going on.
Should be capable of giving them numbers that you can tell people, or you can say, well, we had to hit 80 CFM, and that's about 80. You need to do better than that, probably.
Yeah.
But all right, Steve, I'm gonna let you go. I really appreciate it. We'll have you back again. I'll be communicating with you soon, And
Sounds
we'll do
good.
another show. We'll follow up for this in maybe a month or two. How's that sound?
It sounds great. Thanks for having me, Zach.
All right. Take care, Steve. I'm going to let you go, and I'll see you on the next one.
Okay. Bye-bye.
That was Steve Rogers, guys. Really awesome. Really good show. An area of the trade that a lot of us are weak on. I mean, I would be, if I were in the field still every single day, that would be something that I would be implementing. I've always wanted to have some of the stuff which my company never owned outright. Like you'd have to hire a duct blaster company to come in and do your duct leakage tests. It would be great to do that yourself, and you could use it for troubleshooting then and all sorts of other stuff. I know that'd be a lot of fun. And, it's just what you should do. So we're going to take a quick break. I'm going to come back for our last few minutes of talking here, and I want to make sure that I hit the right button here. So we'll be back in just a second. The best forced air zoning controls in the HVAC industry come from EWC Controls. This includes the Workhorse BM Plus 3000 zone panel, 3 zones, multiple dip switches so you can customize the controls to your particular system install. Another workhorse of the system is the URD and ND dampers. These power open, power closed dampers are both reliable and long lasting. So for the entire life of your system, you won't be replacing your zoning components. And lastly, the innovative SBD2 static pressure bypass with the wireless NFC interface take this whole thing to a new level of precision and reliability, because you can set your system right there at your fingertips to the particular static pressure you need. No more guesswork, no more barometric arms. Go to EWC Controls Incorporated. You can find them online to learn more, and look for them in your local supply house. All right, I got to cut off that commercial because I let the music go on for like 10 seconds, and it's just 10 awkward seconds where nobody's saying anything, so I'm going to stop that. You can tell my buddy Justin Beaver, my partner in crime on a different show down there, and the first thing he says is Captain America. That's a sign of a person that hasn't watched the first half of the show, okay? Because we already made those jokes, Justin. We already made those jokes. I want to thank all the different guys who came and watched. We have the Energy Conservatory watching this show. American Temperature Control, Justin Beaver, the aforementioned Justin Beaver, who only watches the last 5 minutes of these shows and then pretends like he saw the whole thing later. Eric Kaiser, our buddy, who'll be back soon to talk about something. I don't know what, but we're going to talk about something. T-Lec with a thumbs up. If you give the show an actual thumbs up, that would be awesome. If you want to subscribe, feel free to subscribe. Please do. We just passed 400 subscribers on a relatively new channel. I'm really impressed with that. I think that people are responding to these longer form interviews. And basically, these are interviews, but they're kind of a crossover between like a training webinar and an interview. So I think that adds a little bit of dimension to it you don't normally get on a webinar, because I'm your representative here asking questions of these guys, which you would hopefully ask yourself. So I'm right here. And a lot of times people on a webinar are kind of shy. They don't want to speak up. So I'll be the person that speaks up for you. And of course, I'm so charismatic, it's just fun to watch, right? Don't answer that. That's fine. A couple things here. Oh, Justin says he's busy doing gun stuff. Okay, so we won't bother him because it's gun stuff, and that'll, who knows what he'll do with his guns. He's crazy. I'm just kidding. He's a good guy. Couple things real quick. If you want to sign up for live notifications, I will text you before every show, about half an hour before the show. You can find that link in the description. In the description, there's a whole bunch of links. I suggest you go hit them all and explore the far confines of the internet. There's a lot of good stuff down there. The Skilled Trade Up show is our game show. We just had one on Wednesday night. We gave away a Blue Vac Micron gauge. It was awesome. I think, who was our winner? Adam Heisch was our winner. Those prizes are already on the way. I actually gave our second place guy a prize too, because they battled it out, man. It was 1 versus 1, and it was some tough questions, and they did a great job. Great job. So I sent a couple prizes. I sent a couple prizes to the second place winner too. We're going to do that on a semi-regular basis. We'll have another Skilled Trade Up in 2 or 3 weeks. It'll be a lot of fun. So this show is going to happen every Friday. Next week, we are going to have, speaking of Justin Beaver and his many guns, he's going to be on the show next week with our buddy David Richardson, and we're going to talk about residential system capacity. It's going to be a lot of fun. And then the week after that, we are taking a break. We're actually going to have a hangout on the HVAC Shop Talk channel over there on the 12th. And then we're going to come back here on the 19th. I'm not quite sure yet. We're still finalizing those interviews. I have a couple guys that are lying in wait, and we're going to finalize those, and I'll announce those as soon as I know for sure, because I don't want to announce one and then, You know how it goes. Something happens. So, in short, subscribe, like, share. It's the first time that's ever been said on YouTube, right? Subscribe, like, and share. And I want to say one more time, thank you to our guest, Steve Rogers. I want to put his website up, the Energy Conservatory. I'm not going to say all those letters at the front. EnergyConservatory.com. That's where you can find him. And I'm also going to put up his email one last time. srogers@energyconservatory.com. So if you want to reach him, that's where you can find him. He's very responsive. Like all of our guests, he's very responsive. He does a great job with that. All righty, gentlemen. I don't see any ladies out there tonight. I don't know where our ladies are. Where's Susie and Jessica? I don't know where they're at. I feel offended, okay, that they did not watch this. So if you see them in other chats on other channels, be like, where were you guys at tonight? Zach needed you. He broke down emotionally. Just put it like that. They'll believe it. Okay. All right, I'm going to get out of here, guys. That's right. Share with your coworkers. Hey, Doug, you're right on the ball. That's exactly what you need to do. Go to work tomorrow and say, you've been watching Zack Psioda on YouTube, and when they say no, you get in their face. All right? You let them know what's what. I'm out of here, guys. Had a good time. Go relax. Have fun. And I'll see you next time. HVAC training videos. Catch it as a podcast here in the next week or so. I'll see you on the next one.